Welcome back to the channel, everyone. If you saw my last video, you know I'm taking on a massive challenge, bringing this beast of an old milling machine back to life. Before we get our hands dirty, we need to take a brutal, honest look. So, let's start by checking out the machine's current condition. I bought this machine from a scrapyard for a great deal. I fell in love with it immediately, and thankfully, its size is just right for my workshop. Based on the markings, this machine looks like it was manufactured in the USSR around 1986. To be totally honest with you, I have no idea what I'm getting myself into. Bringing this thing back to life is going to be a massive challenge, and I'm definitely not 100% sure I can do it. But if you want to see if we fail or succeed, hit that subscribe button and follow along on this adventure. Okay, the plan is simple, top to bottom. We're going to completely dismantle this machine piece by piece. That means we're starting right at the top with the vertical spindle. Let's get to work. Apologies in advance for any weird camera angles. I'm new to this head camera setup. I'm working on it, and the quality will definitely improve for the next videos. For a heavy assembly like this, I always follow the same technique. I first loosen all the nuts, but I never fully remove them. I keep them threaded on until I see the spindles start to break free. Only then do I take them off. This is a crucial step. It guarantees I don't accidentally drop the spindle, potentially damaging the machine or myself. You'll notice I had to edit out some sections. Unfortunately, my camera battery and memory card just won't let me record the full, non-stop teardown. But I'll make sure to always bring you back for the key steps. Here's the real challenge of this entire project. I have zero documentation for this machine, and the knowledge about it online is practically non-existent. Because of this information gap, every single move I make is nerve-wracking. I'm constantly worried about damaging something vital. After I dismantled most of the machine's procedures, one of my followers kindly sent me the manual for the machine, and I am very grateful to him. He works in the same field, and you will find the link to his YouTube channel in the description. Next, I'm trying to remove the gib from the gibway. It's stuck and rusted, but eventually I will manage. Now we're moving on to the horizontal bearing cover. Do I know if I actually need to take this off? Absolutely not. But since I'm moving forward completely blind without a manual, I'm adopting the strategy of, if it can be opened, I'm opening it. Let's see what secrets are hiding under this cap. These 4 screws are an absolute headache. The standard Allen key I'm using just doesn't have the strength. It's flexing way too much. We need more leverage. So I'm switching over to a hex bit socket. That should give us the torque we need to finally break these things loose. Everything we've done up to this point, the spindle, the covers, the stubborn screws, it was all necessary to achieve this one goal: removing the y-axis of the machine. I can already see that the y-axis is going to be a huge job, but with enough effort, I believe we can absolutely restore it. Before I committed to continuing this massive restoration, I had one crucial requirement. The machine's main gears needed to be in good condition. Without functional gears, the whole thing is just scrap. This is what I'm doing now, opening the cover and checking the gears. Keep in mind, if we find these gears aren't functional, this entire teardown becomes a complete waste of time. And yes, you're right to ask, why didn't I check them sooner? The truth is, I got ahead of myself. So, let's hope my poor planning doesn't cost us the whole project. The moment of truth is now. Yes, the gears looks like new. What a relief. This is the best news for the whole project. Consider it official. Part 2 is happening. Now, we're shifting focus to the back of the machine. I'm continuing the teardown by removing this rear cover. I'm curious to see what secrets are hiding underneath. Let's find out what we're dealing with. It seems that we have now access to the motor belt. Sticking to the plan, top to bottom disassembly. The next thing that has to come off is this heavy motor. Let's get it detached. The motor is now removed. While I missed the shot of it coming out, you can clearly see it sitting behind the machine. Time to remove the table of the machine. And just like that, the table is off. It's now sitting on the floor, and we can really start getting into the structure underneath. And here is the final result. The machine is completely disassembled. I honestly couldn't capture every single step, and I apologize for that. But trying to film while wrestling heavy, rusted parts is truly not convenient sometimes. Trust me, it was always the same process. Basic tools, lots of muscle, and even more patience. Now that the teardown is complete, the real fun begins. Cleaning and restoration. I've decided to start with the vertical spindle. My goal here is to dismantle it to see the condition. The taper of this spindle is MT4. This nut has been an absolute nightmare. I spent ages fighting with it off camera, trying everything. Turns out, it's got a left-hand thread. That's why it wouldn't budge. I was spinning it the wrong way the whole time. Clockwise to loosen on this one. To get a true picture of these parts, they need a serious deep clean. Not only does this guarantee a clear view for inspection, but it also makes them much safer and easier to manipulate on the workbench. Everything is going straight into the degreaser bath now. Unfortunately, I don't have the right tool for this nut. I'll have to use what I have and hope I don't damage it. These nuts are impossible to open. The reason of my struggle was that it is a left-hand thread again. How am I going to take this shaft out? Let me try to remove this cover first. Now that the cover is off, I can remove this right-hand thread nut and tap the shaft free. Ouch. This is a spherical roller bearing. I checked online and the price is very expensive. I hope I can reuse it. I'm now going to disassemble the bevel gear assembly, which is the crucial component that takes the input, our horizontal drive power, and translates it precisely into the vertical motion for the spindle. Next, I will disassemble the bevel gear assembly, which is the crucial component that takes the horizontal drive power and transfer it into the vertical motion for the spindle. That's it for part 1. Part 2 is coming soon for more challenges. I hope that you enjoyed it. Thanks for watching. Please don't forget to like the video and subscribe.